Today we'd like to begin our lesson on probability. It is a topic that, in fact, a whole lot of students don't like, but it is very, very easy. The first thing we'd like to consider is an event. What is an event? An event is a defined occurrence or situation. So the first one we want to consider event. An event is a defined occurrence or situation. Now, the next thing we'd like to, an example, let's consider an example of an event that is tossing a coin and landing head up. And then secondly, okay, scoring a 2 on a true of a die. And then thirdly, winning the first prize of a raffle. Now, the next thing we'd like to consider is possibility space. Possibility or sample space. So we said an event is a defined occurrence or situation. We've given an example of event. Now the next one is possibility space. Now the set of all possible outcome of an event or of a particular event is the possibility space, just like the name, possibility space. Now, from the examples that we have given, the first one says that under the event, tossing a coin and the coin landing head up. So here, our possibility space is either, you see, when you throw a coin, either you get a head or a tail. So the set of all possible outcomes of a particular event. So here, the event, the first one is also tossing a coin and then landing head up. So you know that you can either get a head or a tail. Now the second one says that scoring a 2 on a true of a die. Now on the die, the set of possible outcomes on a die, so the possibility space for the second one, you have 1, 2, 3, 4, 5, 6. That is all. So we now know the difference between an event and then the possibility space. Clearly, let's see, tossing a coin and the coin landing head up. So you can see that this head can also be seen in this, hence it is a subset of the possibility space. The first one, scoring a 2 on a true of a die. Scoring a 2, you can see that 2 is in this set. So clearly, scoring a 2 is a subset of this. Hence, we can conclude, in general, we can conclude that what? An event is a subset of the possibility space. Let's note, an event is a subset of the possibility space. This is so important. We know that a set A is said to be a subset of set B if all the elements in A can be seen in B. And here, clearly, the possibility space, here we have head and tail. And then the first one, we have head up. So clearly, there's a subset of that. And then the 2 is also a subset of the second one. So we know what an event is. We know what the possibility space is. It is so important for us to understand this. Now, let's continue with probability that an event occurs or an event A happens. Now, the probability that an event A happens is the number of ways in which an event A occurs, expressed as a fraction of the number of ways in which all equally likely events, including A, occur. Let me put this on the board. The probability that an event A occurs is the number of ways in which A occur expressed as a fraction of the number of ways in which all equally likely events, including A, okay. So that's the probability that an event A occurs. So in simple terms, we are saying that probability that an event occurs is the number of ways in which A occur all over the number of sample space. Now, we say that probability that an event A occurs is the number of ways in which event A occur expressed as a fraction of the number of ways in which all equally likely events, including the event A, occur. So here we can see that clearly this is a subset of this. So it's the number of ways in which A occurs all over the number of ways in which all equally likely events, including the A. You know that in the possibility space, the set A is also included in the possibility space. And this is the theoretical definition of probability. Let's consider some examples. It is very, very easy. Let's consider some past questions for better understanding. Let's consider this past question, that is SSC 1993. This is very, very trivial. The table shows the classification of students in a school. So they, boy, then we have boys, and then we have girls, boys, girls. If a student is selected, so note, if a student is selected at random from the school, find the probability that the student is a boy. So here, the event is a boy. We know that the event is a defined occurrence or situation. So what they are asking us to find, the event is a boy. So here, I can see that let X be the event of selecting a boy. That is I alpha. Now, what is the number of boys? What is the number of boys? Now, boys in the school, boys is made up of what? That is both the they and then the boy, this. Now, the day student, the boys, we have 45, 50, and then 70. So we have 45 plus 50 plus 70. Now, let's also see the borders. The boys, that is 60, 65, 45, 60, 60, the next one is 65, and then the next one we have 45. Now, when we add all of them, it is giving us 335. 335. Now, we know probability is number of events over number of sample space. So our number of events here, when you add all the boys in the school, is 335. We have to know number of sample space. Now, number of sample space is addition of all those in the school, because it says that what? If a student is selected at random from the school, So we know that the school, we have the student and then the borders as well. So it is addition of everybody. So that is our sample space. So here we have 45 plus 50 plus 70 plus 40 plus 35 plus 55 plus 60 plus 65 plus 45 plus 55 plus 50 plus 30. That is addition of everybody in the school. That is our sample space. Now, when we add all this, we have 600. Now, probability that a boy is selected, we know that is number of events all over number of sample space. Now, what is the event? The event is 335. What is the sample space? The sample space is 600. And when we divide, we are going to get that is 67 all over 120. That is so trivial. Now, let's see the second one. The second one says that a girl in SS3. So we can say that let or suppose Y be the event of selecting a girl in SS3. So what is the number of events? What's the number of events? A girl in SS3. So SS3 girl, we have day, student, and body. So 55 plus 30. So that is 55 plus 30, the event. So a girl in SS3. So that's 55 for the day, student, 30, and this is giving us, that is 85. So the probability, we define probability as number of events. So number of Y all over number of our sample space. Here we have 85 all over 600, and here when we are going to get, that is 17 all over 120. That is also trivial. If you've not subscribed, make sure that you subscribe. We have a whole lot of videos to help you pass your exams with ease. Now let's see the second one. The second one says that if a border is selected. Now the first one says that if a student is selected. So that is the whole school, all those in the students, include the day and then the borders. But here it says that if a border is selected, hence our number of sample space will not change. So with the second one, our sample space becomes only those in the boarding house. So those in the boarding house, we have 60 plus 55 plus 65 plus 50, that is 60, 55, 65, 50 plus 45 plus 30. And when we add all this, this is giving us 305. Now, the event is find the probability that the one is in SS1. So here, alpha, probably we can say that let K be the event of selecting a border in SS1. So hence, our number of, that is the number of K, those in SS1. So you can say that here, let K be the event of selecting a border, in SS1. A border in SS1. So a border in SS1, this SS1, boarding, boys 60, girls 55. So that is our number of events. So we have 60, 55, and this is 115. So probability of selecting a boy, that's number of events all over number of sample space. We know the sample space for the borders is 305. So we have 115 all over 305. And this, we will get 23 all over 61. Now let's see the next one. It says that if a border is selected at random, find the probability that the one is a girl. So here we can say that let V be the event of selecting a border girl. Now, let's see number of events, the number of border girls. So that will be 55 plus 50 plus 30. So we have 55 plus 50 plus 30. 55 plus 50, that's 105 plus 30, that is 135. So probability of selecting a border girl, that will be number of events all over number of sample space. Now, what is the number of border girls? That's 135. And the number of sample space, that is 305. And this cancelling will give us, that is 27 all over 60. Well, this is very trivial. Make sure that you subscribe. Now let's consider this past question. This is NOVDEC 2011, question number 14A. In a class of 60 girls and 40 boys, 24 girls and 21 boys wear spectacles. What's the probability that a student selected, so here a student selected at random from this class wears spectacles. So here the number of sample space that we have to consider is all the students. We have 60 girls and then 40 boys. So here we have, that's number of girls is 60, number of boys is 40. Now, the first one, so our sample space for the first one, sample space, that is 60 plus 40 equal to 100. The same that if a student is selected at random from the class, what's the probability that this from this class wears spectacles? Now let's see those who wear spectacles. 24 boys wear spectacles, 24 girls, and then 21 boys wear spectacles. So let's suppose that X is the event of those who wear spectacles. So number of those who wear spectacles, that is 24 plus 21. And 24 plus 21, this is giving us, that is 45. So probability of getting a student that wears spectacles, that will be 45 all over 100. And this is the same as 0.45. Because probability is number of events all over number of sample space. And those who wear spectacles in the school, that is 24 girls, 21 boys, adding 45. So 45 all over 100. Number of events all over number of sample space. Now the second one says that if a girl is selected, So girl selected, it means that our second one, our sample space will change. Only girls. So for that one, our number of sample space, girls, so that will be 60. If a girl selected at random wears spectacles. Now let's see the number of girls that wear spectacles. Those who wear spectacles is 24. So here, our probability, so let's suppose that if Y is that those who wear spectacles for the girls, that will be 24. So the probability of somebody a girl wearing the spectacle, that will be number of Y all over number of sample space. And this will give us, that is 24 all over 60. Now here, 12 will go in 24 to 12 will go into 65. So we have 2 over 5. That is very easy. Number of events all over number of sample space. Now let's see the third one. The third one is saying that a boy selected at random, a boy. So the third one, a boy selected. It means that our number of events for boys, so a boy selected, so our number of events, or the number of sample space, it will change. Boy, that is what, 40 boys. We have 40, because a boy is selected at random. Does not wear, and then the event is does not wear spectacles. So number of boys that wear spectacles, number of boys that wear spectacles is 21. yes, that is 21. But the total number of boys is 40. So those who do not wear spectacles will be 40 minus 21, which is 19. So probability that that boy doesn't wear spectacles will be number of those who don't wear spectacles all over number of the sample space. And this is 19. Number of those who don't wear spectacles is 19. And then we have the total to be 40. That is 19 over 40. So we have to know the event, and then we also have to know the sample space. We know that the event is a defined occurrence or situation, and the sample space is the possible outcomes of a particular event. Now let's consider this example. It says that the diagram shows that this diagram shows a spinner with 6 numbered sections. So the sections we have 1, 2, 3, 4, 5, 6. 6 numbered sections. Says that some of the sections are shaded. So you can see that these 2 parts are shaded, these 2 parts too are shaded. Each time the spinner is spun, it stops on one of the 6 sections. It is equally likely that it stops on any one of the sections. The question here says that the spinner is spun once. Find the probability that it stops on a shaded section. Now, probability is number of events all over number of sample space. So in this case, the sample space is all the 6. And then says that the event is a shaded section. So let's see the sections that are shaded. We can see that this part is shaded, this part is also shaded, this part is shaded, this part is also shaded. So 4 parts out of 6. So a shaded section, that will be 4 over 6. 2 going into 4, 2 going into 6, 3. So our answer will be 2 over 3. Now let's see the second one. The second one says that a section numbered 1. A section, so the event, section numbered 1. So we can see 1, 1, and then 1. So how many? Number of events, that's 1, 2, 3. So a section numbered 1, the probability will be, that is 3 over 6. And this is the same as 1 over 2. Because the number of events, section numbered 1, that is 1, we have 2, and then 3. Okay, let's see the third one. A shaded section numbered 1. A shaded section. So let's see the shaded section and then which part is numbered 1. We can see this one and that one. So 1, 2. So that is 2. This will be 2 all over 6, all over the sample space. And this is giving us, that is 1 over 3. Now let's see the fourth one. The fourth one says that a shaded section or a section numbered 1. A shaded section or a section numbered 1. So all the shaded section, and then we include this part. So we have 1, 2, 3, 4, 5. That will be 5 over 6. That will be 5 over 6. Now let's see the second question. The second question says that the spinner is now spun twice. Find the probability that the total of the 2 numbers is 20, and then the second one is 11. Now it's spun twice. So twice, we have to create a sample space. Now we have 1. How many ones? That is 3. And then how many 2s do you have? 2. And we have 10. So we have 1, 1, 1. We have 2, 2, and then last one. we have 10. So here becomes 1, 1, 1, 1, 1, 1, 1, 2, 1, 2, 1, 10. Here to 1, 10, 1, 10, 1, 1, 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 1, 1, 1, 1, 1, 2, 1, 2. And here that will be 10, 1, 10, 1, 10, 1, 10, 2, 10, 2, 10, 10. Now we are looking for, that is, says that if the sum is 20, if the sum is 20, then that will be only this, because 10 plus 10 is 20. What's the number of sample space? We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. So the sample space is 36. But then the question says that the spinner is now spun twice. Find the probability that the total of the two numbers is 20. So for it to be 20, then it's going to be just 1 out of 36. So here, because our event becomes just this 1. So our answer for the first one, this one, that will be 1 over 36. So here, that is 1 over 36. Now let's see the second one. It says that the sum is 11. Now the sum is 11. You can see 1 plus 10, 11. 1 plus 10, 11. 1 plus 10, 11. And then 10 plus 1, 11. 10 plus 1, 11. 10 plus 1, 11. So you have 1, 2, 3, 4, 5, 6. So the second one, the answer becomes 6 over 36. Probability, number of events, all over number of sample space. And this will give us 1 out of 6. Now, let's see the C. The C says that the spinner stops on a shaded section. So here, our sample space is shaded section, which is 1, 2, 3, 4. So 4 is our sample space. Now, the question says that find the probability that this section is numbered 2. So out of 1, 2, 3, 4, number 2, that is only this number 2. So number of events, 1 all over 4. So that one will be 1 over 4. Now let's see the second one. Now the second one says that the spinner stops on a section numbered 2. So it stops on 2. That is either this or that. That will be our sample space, which is 2. Says that find the probability that this section is shaded. So it is on this 2, and if it is shaded, then it is this 1 out of 2. So that will be 1 over 2. Now the third, so okay, we are done with the C. Now let's consider the D, the last part. The last part says that the spinner is now spun until it stops on a section number 2. So it spun and it stops on a number, on a section numbered 2. The probability that this happens on the nth spin, so it is happening on the nth spin, is 16 all over 2 over 3. Now let's see, we are being told that it stops on 2. So the probability that it will stop on 2, this is 2, this is 2 out of 6. So the probability that it stops on 2 will be 2 over 6, which is 1 over 3. That it stops on 2. Now, if it does not stop on 2, then it is going to be 1 minus 1 over 3, which will be 2 over 3. That is if it does not stop on 2. That is the probability that an event happens plus the probability that an event does not happen is equal to 1. So in this case, we want to consider the instance where it is not happening. Bear in mind, we are being told that the probability that it is on the 2 is that is on the nth spin. It means that the first n minus 1 spin, it did not fall on 2. Hence, if it is equal to, if the probability that it lands on the nth spin is 16 over 243, then the probability that it does not fall on it, that will be 2 over 3 all to the power n minus 1 times the probability that it is stopping on, that is on 2, which is 1 over 3. And then they are saying that when you multiply these two, we should get 16 all over 2, 4, 3. We are being told to find the n. Okay, so working for n, now we have 2 over 3 all to the power n minus 1 times 1 over 3 equal to 16. But in 16 we can express 16 as 2 to the power 4, and then 2, 4, 3 we can express as 3 to the power 5. Now we can multiply through with 3, so we have 2 over 3 n minus 1 times 1 over 3 times 3 equal to 2 to the power 4 all over 3 to the power 5 times 3. Now this is cancelling this. Indices, we have 3 to the power and 3 to the power 4, so this will reduce to 3 to the power 4. So we have 2 all over 3 n minus 1 equal to 2 to the power 4 all over, that is 3 to the power 4. From indices, now we can have 2 over 3 all to the power n minus 1 equal to 2 over 3 all to the power 4. You know, if you have a n all over b n, we say this is the same as a over b all to the power n. Here, the bases are the same, so you equate the exponents. We have n minus 1 equal to 4. Hence, our n equal to 4 plus 1, which is equal to 5. Now let's consider this past question. This is SSC 1999, question number 8b. 2 coins are tossed and a die is thrown. So we have 2 coins and then a die is thrown. What is the probability of obtaining a head, a tail, and a fall? Now we know that probability is number of events all over number of sample space. So first we have to know the event. Now let's come out with the sample space. Now 2 coins are tossed. We know for a coin you either get a head or tail. So 2 coins are tossed. So if there's the head, there's the tail. We have head, we have tail. So 2 coins tossed. Hence the sample space for this would be, we have head, 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 tail, tail, head, tail, tail. So the sample space becomes head, 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 tail, tail, head, and then tail, tail. Now 2 coins are tossed and a die is thrown. So this is for the 2 coins. Now 2 coins and the die. We know that for a die we have 6. So that is, we have 1, 2, 3, 4, 5, 6. Now the sample space for, so this would be for the die and then this would be for the coins. So we have H, 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 T, T, H, T, T. Now here becomes H, H1, H, H2, H, H3, H, H4. We have H, H5. Here becomes H, H6. Now we have HT1, HT2, HT3, HT4. We have HT5, HT6. Now we have TH1, TH2, TH3, TH4, TH5, TH6. Now we have TT1, TT2, TT3, TT4, TT5, TT6. So this is a set of sample space. Now this we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So the whole total becomes 4 times 6, that is 24. So our number of sample space, that will be 24. Now, what is the event? The probability question says that what is the probability of obtaining a head, a tail, and a fall? So that particular event, let's come out with that particular event: a head, a tail, and a fall. A head, so head and tail. So head, tail, and a fall. Head, tail, and a fall. We have one here. Head, tail, and a fall. Do you have any? One. Head, tail, and a fall. Another one. T, H, fall. Another one. Do you have any other one? Head, tail, and a fall. Do you have any other one? It is only this two. Hence, our number of sample space, because probability is number of events all over number of sample space. So the number of events is 1, 2. All over the sample space. The sample space is 24. 2 go here, 1, 2 go here, 12. So you have 1 all over 12. That is very trivial. Now let's consider this example. This is SSC 1996 question number 8. A coin is tossed twice. We have coin tossed twice and the die is rolled once. So let's count if the sample space for the 2 coins. A coin tossed twice. So coin tossed twice. Now you get head, tail, head, tail. So the sample space will be head, 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 tail, tail, head, tail, tail. Now this is for the coin tossed twice and a die rolled once. So for that one, we are going to have, for the die, we have 1, 2, 6. So 1, 2, 3, 4, 5, 6. Now for the, so this will be for the die, and then this will be for the 2 coins. We have head, 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 tail, tail, head, tail, tail. So with this, we have to come out of the sample space for this event. So here will be head, head 1. We have head, head 2, head, head 3, head, head 4, head, head 5, head, head 6. Now you have head, tail 1, head, tail 2, head, tail 3, head, tail 4, head, tail 5, head, tail 6, tail, head 1, tail, head 2, tail, head 3, tail, head 4, tail, head 5, tail, head 6. We have tail, tail 1, tail, tail 2, tail, tail 3, tail, tail 4, tail, tail 5, tail, tail 6. Now, what is the first one saying? The first one says that find the probability of the following event: 2 heads and a 5. So let's suppose that that particular event is denoted by X. 2 heads and a 5. So this is 5, 2 heads and a 5. So 2 heads, we can see 2 heads and a 5. It is only appearing once. 2 heads and a 5. Only appearing once. 2 heads and a 5. Just one. So the event is 2 heads and a 5. Now, number of elements in this, that is 1. Only 1. You have just one set. So 1. Now, what is our sample space? Number of samples, we have 6 times 4. 1, 2, 3, 4. 6, 4, 24. Hence, the probability of obtaining that will be 1 all over 24. Now, let's see the second one. The second one says that exactly 1 head and a 1 or 2. Exactly 1 head. Let's suppose that the event is Y. Exactly one head, a one, and then a two. Exactly one. So the head should be just one. This is not part because we have two heads. No, 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 no. Exactly one head. So it can either be this or that. This. So exactly one head and a one or two. So it means that this one is part. So we will get HT1, HT1. This is one set. Exactly one head, one or two. So we have this and that. So exactly one head, a one and a two. So we've taken this. This is also part, a one or two. So it means this is part and this is also part. All the others, they are not part. So we have head, tail, two. And then we have tail, head, two. So exactly one head. This is not part. This is not part because we have two tails. No, exactly one head. And then at one or two. So 1, 2, 3, 4. So our number of events, we have 1, 2, 3, 4. That will be 4. So probability of obtaining that will be number of events all over number of sample space. What is the sample space? The sample space is 24. So 4 will go into F1, 4 will go into 24. That's 6. So our answer is 1 out of 6. Now let's see the C. Question C. Question C says that at least one head and not a two. One head and not a two. It means that not a two. It means that all this is not part. At least one head and not a two. No, 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 no. No, no, that's one head and not a two. So this is not this one. No, 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 sorry. And not a two. It means that not a two. So this two is not part. So all this place is not part. But then it says that exactly one head. No, at least one head and not a two. At least one head. So at least one head means one or more and not a two. So we have this one is part. This one is part. So 1, 2, 3. This is not a 2, so this is not part. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, let's count it well. So we have 1, 2. This is part 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15. So let's suppose that that particular event is, let's suppose that it is M. So our number of M, we have 15. So the probability of that M is equal to 15, 24, because the number of sample space is 24. If you've not subscribed, make sure that you subscribe. Now let's consider this past question. This is NOVDEC 2014, question number 13A. It says that a fair coin is tossed 4 times. So let's consider 2 at a time. So the first one, we are going to get so we have head, tail, head, tail. So you have head, 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 tail, tail, head, and then here we have tail, tail. So this will be 2 coins, this one, giving us, so this will be our sample space for this. So hence, if it is 4, so all that we are going to get now, so this is 2, so this 2, so we'll bring 1 here. So we have head, 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 tail, tail, head, tail, tail. Head, 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 tail, tail, head, tail, tail. So this is 2, this is 2. So that will be 4. So here becomes head, 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 head. 4 heads. We have head, tail, head, head. Tail, head, head, head. Tail, tail, head, head. Now this will give us that is head, 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 tail. Head, tail, head, tail. Tail, head, head, tail. Tail, tail, head, tail. Now this will give us that is head, head, tail, head, 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 tail, tail. Now this will be head, tail, tail, head, head, tail, tail, tail. We have tail, head, tail, head, tail, head, tail, tail. We have tail, 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 head, tail, 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 tail. We have 4 of them. Okay, now the first one says that calculate the probability of obtaining. Now what is the number of sample space? 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. So our number of sample space is given as 16. Now calculate the probability of obtaining at least 1 head. So the event is at least 1 head. So our I, let's suppose that X is that particular event. At least 1 head means what? 1 or more head. So at least 1 head. Wow, that would be a whole lot. We wouldn't be able to write them. Now, at least 1 head. This is at least 1 head. 1 or more heads. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Because it is only this one that does not contain 15. That does not contain that is head, at least 1 head. So our number of X is 15. So probability of obtaining at least 1 head, that will be number of events all over the number of sample space. Now the number of events is 15. Number of sample space is 16. Now let's see the second one. Now the second one says that equal number of heads and tails. Let's suppose that Y is that particular event. Equal number of heads and an equal number of tails. It is telling us that if the heads, we should get probably 2 heads and then 2 tails. Equal number of heads and equal number of tails. Now this is not part, this is not part, this is not part, but this is part. So over here, you can see that tail, tail, head, head. That is 1. Because so this is part, this is part, this is part. This is not part, but this is part. This is also part. 2 heads, 2 tails. So that one we have head, tail, head, tail. That is 1. Another one, 2. Another one, 2 is this tail, head, head, tail. Tail, head, head, tail. So now this is 2 tails. No, there's no part. There's no part. This is part. This is part. This is part. This is also part. So we have that is head, tail, tail, head. Head, tail, tail, head. Then you have tail, head, tail, head. So we have TH, TH. What again do you have? Another one? This is not part. Wow, this is part. This is part. Equal number of heads and equal number of tails. So that is what head, head, tail, tail. That's this one. Now let's see. Is this one part? No. Is this one part? No. This is also not part. Now, what is the number of events? Number of events. 1, 2, 3, 4, 5, 6. So that is 6. So probability of getting equal number of heads and tails, that what? Number of events all over number of sample space. 2 going to 6, 3. 2 going into 16, 8. So we have our probability to be 3 all over 8. This is very, very trivial. So probability, number of events all over number of sample space. So we should know the event, and then we also know what? The sample space. Now let's consider this example. If you've not subscribed, make sure that you do that. We have a whole lot of videos to help you pass your exams with ease. You see the books too on the screen. Make sure that you get a copy for yourself. It will give you a very firm foundation in mathematics. Now let's see. It says that a blue die and a green die are thrown simultaneously. We know the sample space on the die 1 to 6, 1 to 6. Now the first one, A says that write down the sample space for this experiment, expressing each element of the sample space as an ordered pair. So the first one, so you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, so let's express as ordered pair. So that'll be 1, 1, 1, 2, 1, 3, 1, 4. Yeah. So we have 1, 4. 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. We have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. We have 5, 6 as well. This is 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and then we have 6, 6. So that's the first one. The B one says that determine the set representation of each of the event listed below. A, the sum of the scores is divisible by 3. Now the BA, so when we add the two, the sum should be divisible by 3. Now 1 plus 2 is 2. It's not divisible by 3, so it's not part. 1, 2, 1 plus 2 is 3, so this is part. Now 1 plus 3, that's 4. It's not divisible by 3. 1, 4, no, 1 plus 4 is 5. It's not divisible by 3. 1, 5, yes, 1 plus 5 is 6, is divisible by 3. So we have 1, 5. Now, 2, 1, this is part, divisible by 3. No, this one is not, but 2, 4 is. 2, 5, 2, 6, no, 2 plus 6, that is 8, not divisible. 3, 1, no, 3, 2, no, 3 plus 3, that's 6. So 3, 3, that one 2 is divisible by 3. 3 plus 4, 7, 3 plus 5, 8. Now 3, 6 is part. 4, 1, no, 4, 2 is part. 4, 3, no, 4, 4, no, 4 plus 5 is 9. That one is divisible by 5. 4 plus 6, that's 10, not divisible. 5 plus 1 is part. 5, 2, no, 5 plus 3, no, but 5, 4 is part. 5, 5, no, 5, 6, no. 5, 5, that would be 9, 5, 6, 11, no. This is 7, 8, 9. This is part. 6 plus 5, that's 11. 6 plus 6, that is 12, and that is also divisible by 3. That's divisible by 3. That's the first one. Now let's see the B. The B says that the sum of the scores is odd. B. When you add the 2, it's odd. Now 1 plus 2. 1 plus 1 is 2, is not odd. But this is part, so we have 1, 2. When you add, it's odd. 1 plus 2 is 3 odd. This one is not, but this one is. So we have 1, 4. We have 1, 6. When you add 1 plus 5, this will give us even, but it should be odd. 2, 1 is part. 2, 2, no. 2, 3, yes. 2, 4, 2, 5. When you add, odd, even, 3 plus 1, 4, but then 3, 2 is part. 3, 2 is part. 3, 3 even, 3, 4. 3, 4 is odd. 3 plus 5, 8. No, 3 plus 6 is part. When you add, you should get odd. 4 plus 1 is part. 4 plus 2, no, 4 plus 3, 7. 4 plus 3, that is 7. 4 plus 4, 8 is not part. 4 plus 5, so 4, 5. 4, 6, no, it's not part. 5, 1, no, 5, 2. 5, 2. 5, 3. 5 plus 3, 8, no. 5 plus 4, 9. 5 plus 5, 10 is no. 5, 6. That is part. 6 plus 1 is 7. Yes. It should give us odd. That is part. 6 plus 2, 8 is not part. 6 plus 3, 9. 6 plus 4, no. 6 plus 5, no. Yes, 6 plus 5, 11. 6 and plus 6, no. It is not part. Now let's see. So that is our B. Let's see our C. Now, the C is saying that the scores differ by at least 3. So when you subtract 3, that means 3 or more. 3 or more. 3 or more. Now, 3 minus 1 minus, no. So this one is part. 4 minus 1 is 3. Yes, so that will be 1, 4, 1, 5, 1, 6. All this when you subtract, you get at least. Now 2, no. 2 and 3, no. 2, 4, no. 2, 5. So 2, 5 and 2, 6. So you have 2, 5, 2, 6. Yes. The difference is more than 3 or more. This one is not 3, 5, no. 3, 6 is part. 4 minus 1, yes. Yes. 4, 2, no. 4, 3, no. 4, 4, no. 4, 5, no. 4, 6, no. 5, 1, yes. 5, 2, yes. 5, 3, no. 5, 4, no. 5, 5, no. 5, 6, no. Now 6, 1, yes. At least 3. 6, 2, yes. That's 4. 6, 4, no. 6, 5, no. The last one, that is 6 minus 3 is 3. So we have 6, 3. Now let's see the D. The D says an odd score is obtained on the green die. So the D says an odd score is obtained on the green. It says that a blue die and a green die. So this is our blue and then this is our green die. Now we are being told that an odd score is obtained on the green die. It means that on the second one we should have an odd. So 1, 1 is part, but the 1, 2 is not part because the green one is 2. But it says that an odd on the green die. It means that here, the first one, that will be 1, 1, 1, 3. So the second one should be odd. So odd. So that, the next one, that will be 1, 5. And then 1 6 is not. So we have 2 1. The second one should be odd. 2 2 2 3. So we have 2 3. Now the next one 2 5. Because the second one should be odd. You have 3 1. 3 3. 3 5. And then you have 4 1. 4 3. 4 5. And then we have 5 1. 5 3. 5 5. And then we have 6 1. 6 3. 6 5. Because an odd score on the green die. So you can see that all the second one we have odd. Now the C says we should calculate I, number of A intersection B, number of elements in the A intersection B. So first, so I'll say I, we need to know A intersection B, the elements which are common to both A and B. Now common, they are the same. So here we can see 1 2 here, 1 2 here. So that is 1 2 1 5. Do you have 1 5 here? Do you have 1 5 here? No, we don't have 1 5. 2 1. Do you have 2 1 here? Yes, we have 2 1. Common. They are common. Common. 2 4. Do you have 2 4 here? No, we don't have 2 4. 3 3. 3 3. Do you have 3 3 here? No. 3 6. Do you have 3 6 here? Yes. So we have 3 6. Now let's see 4 2. Do you have 4 2 here? No, we don't have 4 2. The next one 4 5. Do you have 4 5? Yes, we have 4 5 here. We have 4 5 over there. 4 5. 5 1. Do you have 5 1 here? 5 1 no. 5 4. Do we have 5 4 here? Yes, we have 5 4. 5 4. And then so you have 6 3. Do you have 6 3 here? Yeah, there's 6 3 there. So you have to come out with all of them, the elements which are common, the same. 6 6. Do you have 6 6 here? No, we don't have 6 6. So number of elements in this, number of elements in A intersection B, how many? 1 2 3 4 5 6. If you've not subscribed, make sure that you subscribe. Now let's see, the I says the probability of A union D. So probability of A union D. And this is equal to number of events. So number of A union D all over the number of sample space. And the number of sample space we know is what? 36. Now, so we need to know A union D first. Elements that belong to A or D or both. So we need to know our A union D. Element that belongs to A or D or both. Now, let's see. But then we know we don't repeat them. The elements shouldn't be repeated. So A and then union are V. Now, so first 1 1 1 2. So we have 1 1 1 2. Do you have 1 3? Yes, 1 3. 1 3. Do you have 1 4? No, 1 4. Then we have 1 5. 1 6. 1 6. Do you have 1 6 here? 1 6. No. 1 6. No. 2 1. Yes. So 2 1. Do you have 2 2? 2 1. 2 1. 2 1 2 2. 2 2. No, there's no 2 2. 2 3. Yes, there's 2 3. So we have 2 3. Do you have 2, 4? 2, 4. Yes, there's 2, 4 here. 2, 4. Yes, we have 2, 5 in the other one. 2, 5. Second is odd. 2, 5. And then 2, 6. Do you have 2, 6 here? No, 2, 6. No, 2, 6. So the next one will be 3, 1. Yes, second is odd. 3, 1. But must be here. 3, 1. 3, 2. Do you have 3, 2 here? Do you have 3, 2 here? 3, 2, 3, 2. 3, 2. No. But we have 3, 3. No, 3, 2 here. 3, 3. 3, 3. Because 3, 3 is here. 3, 4 is not here. 3, 5. Yes, there's 3, 5 here. 3, 5. Now the next one, 3, 6. Do you have 3, 6? No, there's no 3, 6 here. But we have 3, 6 here. 3, 6. Now 4, 1. Yes, there's 4, 1 here. So we have 4, 1. 4, 2. Let's see. Yes, there's 4, 2 here. 4, 3. 4, 2. 4, 3 will be in the other set. 4, 3 will be in the other set. 4, 4. No, 4, 4. No, 4, 4. 4, 5. Yes, 4, 5. 4, 6. Do you have 4, 6 here? No. 5, 1. Yes, 5, 1 will be in the other set. 5, 1. That is in D. 5, 2. Do you have 5, 2? No. 5, 3. Yes, 5, 3 will be in the set D. 5, 3. 5, 4. Yes, we have 5, 4 here. 5, 4. 5, 5. Yes, 5, 5 will be in the other set. 5, 5 will be in the other set. 5, 6. No. 6, 1. Yes, 6, 1 will be in the other set. So we have 6, 1. 6, 2. Do you have 6, 2 here? No, we don't have 6, 2, but you have 6, 3. We have 6, 3. 6, 4. There's no 6, 4 here. 6, 5. Yes, there's 6, 5 in the other set. Second should be odd. 6, 6. 6, 6. 6, 6. Yes, we have 6, 6. Now, what is the number of elements? Let's count them. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Hence, the number of A unit, we have what? A union D, that is 24. And then the number of sample space, we have 36. Now, 12 will go into 24 2 times. 12 will go into 36, that is 3 times. So our answer is 2 over 3. That is very, very easy. So probability, that's number of events all over number of sample space. We should know our event, know our sample space, and express it as a fraction. So the number of ways in which probability that an event A occurs, the number of ways in which A occurs all over the number of ways in which all equally likely events, including A, occurs. So that is it. So this is our first part. In our lesson, we would be continuing with the addition law and then also get to know about mutually exclusive independent events, and then we add other ones also to it. It's going to be very, very interesting. Make sure that you are part, and also invite your friends who don't know about this page. Let them come and then learn for free. No pain, no gain. Mathematics is not a spectator sport, so get active. Now, we know that the height reached and kept by great men were not attained by sudden flight, but they, while their companions slept, they were toiling upwards in the night. Have you seen any man doing so well in any other thing? It means that whilst the others were sleeping, that particular person was busily learning. When you sit down and then you learn, you know. Get time for your books, get time for yourselves, and you are going to do very, very well. You get A in elective maths, and make sure that you get a copy of the books that you are seeing on the screen. Bye-bye.